Right. So I'm going to very quickly talk about double curvature. But before I do that, in order to explain that, I need to explain something that is planar. So essentially, any object that you have in Rhino, where essentially you have flat pieces, these are essentially called planar pieces. So like all these pieces are flat, even if they're at an angle. Or I'll just make a slightly different object. Again, they might have different angles and different creases to them. Like here, there's a crease with an angle. But essentially, these individual surfaces are essentially all planar. They're essentially all flat. So if I were to unroll these, I should be able to unroll these without any issues. And I should be able to get those pieces. And the same goes with the box. I should be able to unroll those with any issues. But when you're unrolling something that has a single curvature, such as, let's like just do a cylinder. I'll be able to unroll this without any issues because it's just a single curvature. So I would have essentially the top and the bottom pieces, and then the entire tube. It would be no different as if you were just to get a sheet of paper and just to roll it up as a tube. The same could be done with a cone. I can unroll this. And again, this is just a single curvature, so this is possible. But if I have double curvature, that's where I run into some issues because it's just not possible to unroll something that has double curvature. The easiest example is the torus, or it looks like a donut. If I do this and I try to unroll it, if I look at my command line, it says, if you want to unroll it anyway, try using smash command or adjust the relative tolerance on the unroll surface command line. Unrolling doubly curved surfaces will produce inaccurate results. So technically, you cannot unroll surfaces that are doubly curved. I know one of the options it says is to use the smash command or to change the tolerance, but your results are not going to be accurate. It's essentially, you're essentially asking the computer to like force this thing to be unrolled. The easiest example that kind of shows this is if you get a piece of paper and if you were to make a tube. So if you essentially roll up that sheet of paper and make a tube out of it, something like this, obviously that's possible, you can do this. But the second you try to bend this sheet of paper so that the top of the tube and you tries to match up with the bottom of the tube, this entire sheet of paper is going to crinkle. And that's essentially what the torus is doing. First, it's a tube going in essentially a circle in one direction. And then the top and the bottom, like the top of the tube is connecting to the bottom of the tube going all the way around. And in Rhino digitally, it can do this because it's treating this as if it's like a piece of plastic rubber that's elastic and stretchable. But in reality, if you're doing this out of a flat stock material, it's impossible to unroll. So just be very careful when using curvature because you can run into issues of double curvature.